Welcome to Riparian Function and Management, a new online class created by Sky and Mary Kate at Nueces River Authority, piloted by Sul State University through the Sustainable Ranch Management Program under the direction of Dr. Bonnie Warnock. Much of the photographic content for this course was developed by Steve Nelly, Kenneth Mabin, and Ricky Lennox, riparian experts. The purpose of this course is to introduce the components of physical function in a river system's riparian area and to build understanding about how riparian conditions can be influenced by management decisions. This is information that has not been widely available in Texas. Hence, our riparian areas are among the least understood or most misunderstood pieces of the Texas landscape. In the next 6 weeks, we will evaluate hydrology, vegetation, and soils, the three components of physical function, and we will discuss the natural processes that occur within the riparian zone. Students will learn to recognize the functional condition that allows riparian areas to withstand and benefit from floods and droughts. We also will teach that functional conditions produce desirable values such as clean water, sustained flows, fish and wildlife habitat, livestock forage, recreation, and aesthetic beauty. Together, we will explore cause and effect relationships, degradation and recovery processes, and learn to identify activities that may be hindering riparian recovery. Successful completion of this course will be marked by the student's ability to evaluate riparian function conditions, to identify potential for improved functional condition, to identify hindrances to riparian recovery, envision recovered conditions, as well as identify limitations to recovery capability. The course syllabus spells out the details on reading material, required books, course structure, grading, and schedule. You will find the downloadable reading material at remarkableriparian.org. A copy of the 3rd edition Remarkable Riparian Field Guide and Owner's Manual will need to be purchased from that site. You also will need to read A View of a River and Water, Rivers, and Creeks by Luna B. Leopold. The course includes a mandatory field trip which is offered at 2 different locations. If your participation in one of the planned field trips is not possible, please contact me to discuss an alternate for credit activity. Video lectures will be delivered on Monday, Tuesday, Wednesday, and Thursday each week. Each lecture or set of lectures will be available for a 24-hour period beginning at 12 noon each day. If you miss a lecture, you'll need to contact the instructor to arrange for a makeup viewing. The week's lectures, readings, videos, and homework will be discussed on Fridays via discussion boards. Students must participate in the discussions. Evidence of minimum participation will be indicated by posting at least one comment and responding to at least one comment. A quiz will be held each Saturday based on the previous week's material. The test will be available for completion during a 24-hour period from 12 noon on Saturday until 12 noon the following Sunday. If you miss a quiz, you will not be allowed to make it up. Grading will be based on participation, quizzes, final exam, and participation in the field trip. To begin this lecture, let's make sure we have a common understanding of what is riparian. This is a term that has just come into common usage in Texas in the past 10 to 15 years, even among land management professionals. A riparian area or zone is the part of the landscape that flanks rivers and streams, shown in blue on this picture. It does not include the channel or the water. It's the land that lies between the drier uplands and the wetted channel. The riparian area pictured here lies along the Concho River near San Angelo and can easily be distinguished as the greener, more lush area, in contrast to the less green uplands. It's the ribbon of land that follows and interacts with the waterway. The riparian areas include the stream bank, a floodplain, and all things within that area: plants, soil, logs, organic debris, and such. Areas adjoining lakes and reservoirs are also considered riparian, and when they are large and saturated, they're often referred to as wetlands. We use the term lentic for water bodies that contain standing water. This course will focus mainly on riparian areas that lie near running water, known as lotic water bodies. In a greener overall landscape, the riparian area may not stand out so boldly. This riparian area can be delineated by the presence of plant types. Riparian plants have some special characteristics, and you can begin reading about them in your remarkable Riparian Field Guide. On the Rio Grande Plain, riparian areas often contain some of the same vegetation that you might find in the uplands. Mesquite and huisache, both classified as UPL or upland plants, are common, but they're also sometimes found growing in close proximity to riparian grasses and sedges. In this flatter country, streams can become braided with multiple channels. The riparian area along the Nueces in McMullen County, near Tilden, is most easily identified by the presence of flood debris as evidence of recent flooding or inundation. A similar situation can be seen on this creek in LaSalle County near Cotulla. The bright green plants here are spiny aster and eastern gamma, both facultative riparian grasses, which are able to thrive in both wet and dry conditions. These, combined with evidence of inundation by floodwater, are clues to identifying this riparian area. Many publications have sought to define the extent of riparian areas, but none have proven 100% meaningful in on-the-ground applications. The channel and valley slope and type, presence of riparian plants, evidence of frequent inundation, evidence of water storage, and other factors may indicate riparian location and extent. That size and location can vary greatly between rivers and along the same river, and can change over time. Sometimes it becomes helpful to use an average width in planning and estimating restoration and preservation activities, but that number is most meaningful when based on actual conditions. Widening of a riparian area and narrowing of a channel is typically indicative of improving health. Conversely, narrowing of riparian areas and widening of the water channels can characterize hindered recovery or comprised function. Management practices can influence riparian area size, as well as functional condition. We sometimes say that an area wants to be riparian but is hindered by the presence of one or more hindrances. Along coastal creeks and in areas of tidal influence, riparian areas can be very wide. In places, it may be difficult to find their outer extent. Coastal areas may contain both lentic and lotic watercourses, and the land flanking them may be equally referred to as wetland or riparian. Riparian areas also exist in cities and can be found along urban drainage ways. The width of urban riparian areas is often said to be a certain number of feet wide, but this is for convenience in planning. A riparian area, even in an urban setting, will be as wide as it can be, depending on the landscape being drained. And for the services they provide, we want riparian areas to be as wide as possible. To determine extent of existing riparian areas and to identify opportunities for the expansion, one must spend time on that creek or river. Before we leave the subject of what is riparian, let's look at some official federal agency definitions. The Bureau of Land Management definition calls for influence of permanent water and excludes ephemeral streams. Ephemeral streams run only as a result of runoff and maintain no connection to a water table. Ephemeral streams are commonly referred to as arroyos, draws, or ditches. We will discuss stream flow classification in our next lecture. For now, you will note that riparian and wetland definitions are tied to a regular presence of water. The U.S. Fish and Wildlife Service says riparian areas are plant communities next to water bodies, and they are usually transitional between wetlands and uplands. The U.S. Forest Service says riparian areas are 100 feet from a perennial stream. The U.S. Department of Agriculture says they are ecosystems along a watercourse, influenced by free or unbound water. All of these definitions seem to have been created for a purpose, either programmatic or regulatory, and are not entirely meaningful in managing riparian land for functional conditions. We have a big state in Texas. About 168 million acres are contained with the state's boundary. This vast landscape is drained by creeks and rivers of many sizes and shapes. The tiny blue lines shown on this map illustrate a kind of vascular system, a set of natural drainways that transport and deliver water and sediments to larger and larger streams, and eventually to coastal bay or Gulf of Mexico. Lots of life, almost all life, depends on this system. In Texas, the water and sediment is delivered by more than 11,000 named streams and many more unnamed tributaries. Think about riparian areas that flank these blue lines. They are a small piece of the overall landscape. Most of the land in Texas is upland. Most of the land and natural resource management efforts in Texas have been focused on the upland landscape. The tiny riparian landscape has been mostly ignored. It has been the stepchild, so to speak, of resource management programs and the sacrifice area of many agricultural operations. According to the National Research Council, the percentage of riparian and riparian-related publications and citations within a nationwide literature search reveals a steep increase in recent years. The last 3 decades show an exceptional trend toward increased research activity on a wide variety of riparian topics. These trends imply that many current natural resource managers, elected officials, and the general public acquired their educational backgrounds during a period when riparian issues, functions, and values were likely never mentioned or discussed, much less emphasized. Even in today's era of general environmental awareness, educational programs have been slow to incorporate subject matter that addresses the importance of riparian areas or how they work. Now, in Texas, we are realizing, as most other western states have, that riparian areas, despite their small size, are responsible for providing a disproportional set of important water benefits, and that they have been mostly misunderstood. Riparian conditions directly influence water quality and quantity, and area critical to health of a stream. Management decisions that directly influence riparian health areas are extremely influential in this regard. Based on the 1% estimate, there may be about 1.6 million acres of riparian land in Texas, a size you could really wrap your mind around, making riparian areas a good place to focus limited resources to produce water-related benefits. Regardless of how it's defined, people have always known that riparian areas were special. This is evidenced in Texas by the early survey plats designed along creeks and rivers. The early surveyors traced creeks and rivers in platting land in much of Texas. The official form for recording a survey called for the location situated on the waters of a named river or citing the tributary to a named river. These early plats recognized riparian function and stream morphology in calling for boundaries defined by the meanders of a stream. In the early 1900s, land ownership began to become oriented along railroads and streets instead of rivers. This created a new set of values and a different community focus. However, we are now seeing this paradigm shift back. There has been a resurgence in the appreciation of values associated with running water. This is evidenced by real estate advertisements of the day marketing live water and subdivision plats that assign higher values to lands closest to the water. Texas cities are also experiencing growth in creekfront developments. Shoal Creek restoration and development in Austin is attracting billions of dollars in investments around a restored and functional riparian area. The project is designed to buffer floodwater runoff and become a host to lush, natural surroundings in the midst of high-density urban development. Creek and river-focused urban events, focus groups, adopt-a-creek groups, watershed councils, etc., they all indicate some of the new riparian focus. Follow the money in Texas cities and you'll find it leading to restored functional riparian areas. This new urban development trend may be cueing from the understanding that people value water. Whether in the city or in the country, different people value different things about creeks and rivers. For example, the people in the photograph on the upper left are enjoying watching a bird, while the gentleman in the lower right is appreciating the big, healthy eastern gamma plant for its forage value. Almost everyone appreciates a place to cool off on a hot summer day. Some recognized values include clean water. They include reliable supplies of water, abundant livestock forage, fish and aquatic habitat, wildlife habitat, as well as natural beauty and recreation. In this class, we will focus on the physical conditions that generate these values rather than the values themselves. So for now, let's set these aside along with our existing paradigms and start a fresh approach to riparian understanding. Much of this course will focus on physical function. A properly functioning riparian area along moving water is defined as one that has enough stuff. Vegetation, landform, it has large woody material, all enough to first and foremost dissipate stream energy, stabilize banks, reduce erosion, trap sediment, build or enlarge the floodplain, to store water, floodwater retention, groundwater recharge, and sustain base flow. And if these processes are occurring, then they will produce water quality, water quantity, forage, aquatic habitat, wildlife habitat, recreational value, and aesthetic beauty. So it is physical function that produces the values that we appreciate and demand from the creeks and rivers. This is the key concept of this course and valuable concept that can be applied to creeks and rivers anywhere on the planet. Let's take a look at what riparian function looks like on the landscape. Compare these two creeks. You can easily see function versus dysfunction. Here are two other examples where you can see a functional creek and then immediately to the right, a dysfunctional creek. Look carefully here. The riparian area on the left is functional and the riparian area on the right is not. Here you can see functional and dysfunctional areas on the very same creek where management can be seen making a difference. And here you can see the same exact location 7 years apart. Management can make a huge difference in functional condition and value production. By now, you're probably beginning to see some of the things that constitute the difference between functional and dysfunctional riparian conditions. That same seeing can help decipher the presence of functional and dysfunctional riparian condition even in urban settings. A common characteristic of function involves the storage of water. We often refer to riparian areas that store water as a riparian sponge. A riparian sponge holds water and it releases it very slowly. When the sponge is absent, it's often because there is not a functional condition. There's not enough stuff. There's not enough stuff to first and foremost dissipate stream energy. So, water runs off and down the stream faster, taking with it the essential fine organic rich particles that could be trapped in the riparian area, which would help hold and store the water. When the water holding capacity of riparian soils is lost, there is no sponge present. Therefore, the water simply runs off and downstream, leaving in little storage for slow future release. The functional and dysfunctional condition of riparian areas, almost anywhere, can be compared and contrasted by examining this very important characteristic, the presence of a sponge. The riparian area along this creek in Gillespie County is not functioning very well. It is clearly missing adequate vegetation, landform, or large woody material to dissipate stream energy, so none of the other processes can begin to occur. There is no sponge present, and therefore the following are inhibited: energy dissipation, stabilized banks, reduced erosion, sediment trapping, enlarging floodplains, floodwater retention, groundwater recharge, and sustained base flow. All are inhibited. The riparian area along the Leona River and Uvalde is functioning. It has adequate vegetation, landform, or large woody material to dissipate stream energy, so all of the other processes are occurring. There is a sponge present. Today's lesson covered where riparian areas can be found on the landscape and what functional riparian areas look like. For your homework, observe a creek or a river and take time to note the riparian condition. Does it appear functional or dysfunctional? What clues do you see that lead you to this estimation? Be prepared to comment on your observations in your Friday discussion, and you may want to take a photograph of this site. Be sure to follow safe procedures when observing creeks and rivers, especially where traffic and bridges are involved.